Howdy guys, welcome to another stats video. We're going to talk about discrete random variables. Um, so if we have a dice game and we're rolling a pair of six-sided die, if the sum is 7, we win $5. If the sum is 2 or 12, we win 15. Otherwise, you lose 3. So we're going to pretend that we've played this game 20 times and record your winnings or losings after each round. So let's say the first time we won 15. Lose 3. I'm just making these up. Lose 3, lose 3, lose 3 on the 6th, lose 3. Because we're going to lose 3 probably most of the time, right? Lose 3, win 5, lose 3. And you could do a simulator if you didn't have any dice and do, 20 trials and you might end up with these numbers. So what's the sum? Remember, that's a sigma notation, just meaning the sum of. What's the sum of all the x's, all the results? Well, for this list, it's $6. So that means we walked away and won 6. So what's the average winnings per trial? Well, that'd be that $6 divided by the 20 trials, which is, we averaged a 30-cent gain off of each ones. But the way this game is set up, it could be that you lose overall, right? And that you lose on average a little bit of money every trial. The standard deviation of winnings is 5.07. Remember, if we entered these guys in as a table in Desmos, it will tell you what that standard deviation is. And if we ever come back to the classroom, I'll show you guys how to use a TI calculator to discover that standard deviation. Remember, we could figure it out on our own if we wanted to. We take this sum and divide by n minus 1 and take the square root of that guy. So we don't have a definition for random variable yet. Its notation usually is written as a capital X. It's a variable whose possible values are numerical outcomes of a random phenomenon. So they can be discrete or continuous. If they're discrete, it's a countable number of outcomes. If it's continuous, it's an infinite number of outcomes. So if we're looking at the amount of money won in the dice game, that would be a discrete random variable. You can find its probability distribution. So a probability distribution just means a table of probabilities. So the probability distribution for this dice game, and you guys are going to do this for your casino games, is winning $5. And the way that we win $5 is if we get a sum of 7. So the probability of rolling a 7 and that's equal to 1/6. Because there's 6 ways to roll a sum of 7 out of 36 possible choices, and 6 over 36 reduces to 1/6. So what about for winning 15? Well, this is the probability of rolling a 2 or a 12, which is 2 over 36, or 1/18. Losing 3 is going to happen most of the time. So if we take all 100% of the possibilities and we subtract these other two options, we're going to end up with the probability of losing 3. Okay, that's 7/9. So 7 out of every 9 times we ought to lose $3. Okay, so we can find the mean and the standard deviation, or the mean and the variance of each of these guys, and using the variance we can find the standard deviation. So the mean usually it's also known as expected value. Okay, it's the sum of each of these outcomes times their individual probabilities. So the expected value for Rx, our discrete random variable x, is the first possible winnings times its probability of happening plus the second possible outcome times its probability of happening plus the third possible outcome times its probability of happening. So we should expect to lose 66 cents, 67 cents if you round it to the nearest cent, or negative 2/3 of a dollar every time we play. So this table of data of results that I made up here is probably a little generous, right? The variance, remember, this summation notation just means that we're adding, right? And these x sub i's are individual and then mu sub x, remember, is our expected value, e of x. And then p sub I are the probabilities of x happening. So the way variance is going to work is it's going to be the sum of these differences, so 5 minus the mean, negative 2/3, squared times the probability of getting a 5. Whoops, it's 1/6. Plus, and we'll keep going, but I want to be clear about where these come from. So this is for the first column. 5 is the value of x minus the expected value. So expected value's got two different notations. It's mu sub x or e of x. And we said that that was this guy, right? And then you square that and you multiply it by this column's probability. So we're going to do that for each of these guys. The next one is 15 minus negative 2/3. The expected value doesn't change. Squared times its probability. Plus negative 3 minus negative 2/3. Squaring that difference, and we're multiplying it by its probability, which is 7/9. Over here to this corner, and it gets a little excited. I think I hit this button down here, keyboard, and it won't go away sometimes. Okay, so our variance is 23.22. You might go, well, what is the variance? Variance in general is how spread out data is, right? It's a little bit hard to imagine what variance is in probability, but it's the spread of the probabilities in general, okay? So what is the standard deviation? It's the square root of this variance. So for us, it's the square root of 23.22, which is $4.82. So what does that mean? That means that most of the time, earnings will fall within $4.82 of the expected value. Which is negative 0.67 to the nearest cent. Okay. All right. Let's see. Next example is a casino offers a game where you roll 3 6-sided dice. If all 3 dice are 6s, you win the mega jackpot of $50. If 2 of the dice are 6s, you win $20. If you get 1 6, you win $6. And if you don't have any 6s at all, you lose $6. What's the expected profit of the game? Well, we're going to build a probability distribution. Let's define X first. X is amount player wins. And we got 3 situations here. Could win 50. That's 1 out of 216. And this is 3-sided dice. So let's see. This is just 6 times 6 times 6, or 6 to the third. There's only one way to get 3 6s. It's like our table of rolling 2 dice, but there's 3, so it's kind of hard to see in a table. How many ways are there to get 2 dice? Well, we know this denominator is going to be 216. It turns out there are 15 different ways to get 2 6s. And you could sort of write out options, right? You could have a 1, a 6, and a 6. You could have a 2, a 6, and a 6, and you can keep going like this, right? And list them out. But there are 15 different ways. Remember, you could also have a 6, a 1, and a 6. These are different rolls, right? So if you listed all those out, you'd have 15 out of the 216 where you had doubles. What about singles? Well, for a single 6, we're going to win $6. Well, here, let's write this out. The probability that X is 50 is the probability of rolling 3 6s, which is 1/6 cubed. Okay? That's where our 1 over 216 comes from. The probability that X is equal to 6 let's do this. The probability that X is equal to 20 is equal to 1/6 the first roll, 1/6 the second roll. So there are 2 6s, and then 5/6 is our third roll. But because order matters, 3 ways to happen, we're going to multiply that thing by 3. That's where the 15 out of 216 happens. And this is an ideal way of doing it because you don't have to list those things out. And that gets painful. If you think about the ways you could get a 6, it's going to be painful to write all those out because there's 75 different ways that could happen. And you don't want to do that. So this is probably the smartest way of doing it is to write out the probabilities in order. This is a 6, this is a 6, this is not a 6, and then there are 3 different ways that you could order that.